You believe time is passing. You feel it every second. But modern physics says something far more disturbing. There is no universal now for anything to pass through. No shared present, no cosmic clock, no evidence that the universe itself is moving from past to future. The sensation of flow, the feeling that moments are slipping away, does not come from reality. It is generated by your brain stitched together for survival, not truth. At the deepest levels, we can describe the equations are silent. Nothing ticks, nothing advances, nothing waits. So if the universe is not flowing, why does your life feel like it is? And what exactly are you moving through if time itself isn't real? To trust the flow of time is not irrational. For most of human history, it was the most reasonable assumption we could make. In the late 17th century, Isaac Newton formalized this intuition into the foundation of classical physics. Time, he argued, was absolute and invisible universal parameter that advanced at the same rate everywhere independent of motion, matter, or observation. In this framework, the universe behaved like a perfectly synchronized machine. Every event could be placed on a single, shared timeline. Every observer agreed on what now meant. This assumption worked extraordinarily well. It explained falling apples, planetary orbits, and the mechanics of everyday life with stunning accuracy. For centuries, there was no practical reason to doubt it. But at the beginning of the 20th century, that foundation fractured. Albert Einstein demonstrated that time was not a global variable after all. It was local, flexible, entangled with space itself. The rate at which time unfolds depends on how fast you move and how deeply you sit in a gravitational field. There is no master clock governing the universe, only countless local clocks, each following its own path through spacetime. For decades, this revelation remained largely philosophical. At human speeds and scales, the discrepancy was too small to notice. The legacy system continued to function until we began to build technologies that demanded absolute synchronization. Today, the assumption of a universal now is no longer just an outdated idea. It is a measurable fault in the infrastructure of modern civilization. And the first clear error report doesn't come from a distant galaxy. It comes from a system you use every day. The investigation begins in medium Earth orbit, where a constellation of GPS satellites circles the planet. These machines are the heartbeat of our global navigation infrastructure, and they provide the most undeniable forensic evidence that time does not behave as a universal constant. For a GPS receiver in your phone to pinpoint your location, it requires precise synchronization with the atomic clocks on board these satellites. If Newton's absolute time were correct, if time flowed at the same rate in orbit as it does on the ground, the engineering would be straightforward. But the universe does not run on Newton's protocol. Because these satellites are traveling at 14,000 kilometers per hour, their high velocity engages the protocols of special relativity. Relative to an observer on the ground, the satellite's internal clock ticks slower by about 7 microseconds per day. However, velocity is not the only variable at play. The satellites are also positioned 20,000 kilometers above the Earth's surface, far away from the crushing gravity well of the planet. According to Einstein's general relativity, gravity acts as a brake on the flow of time. With less gravitational stress, the clocks in orbit run faster by about 45 microseconds per day. When you reconcile these two relativistic effects, you are left with a net discrepancy. The satellite clocks run exactly 38 microseconds faster than clocks on Earth every single day. To a human, 38 microseconds is imperceptible, a rounding error, but to a navigation system based on the speed of light, it is catastrophic. Light travels 300,000 kilometers in a single second. In 38 microseconds, it travels about 11 kilometers. If engineers did not upload a relativistic patch to correct this drift, if they trusted in the illusion of absolute time, the entire global positioning system would accumulate a navigational error of 10 kilometers per day. Within days, the system would become useless. The fact that your map app works is proof that time does not run uniformly. Its measured rate depends on speed and gravitational context. But the failure of synchronization goes deeper than just clock drift. Because the deeper problem isn't that clocks disagree, it's that the universe offers no built-in way to define simultaneous at a distance. The very concept of now, a simultaneous moment shared across the universe, is technically impossible. This is due to the hard bandwidth limit of the cosmos, the speed of light. We intuitively assume that when we look at the universe, we see it in real time. But information takes time to travel. Light covers approximately 30 centimeters in 1 nanosecond. This means that even when you look at your own hand, you are not seeing it as it is, but as it was a fraction of a nanosecond ago. You are always trapping yourself in a bubble of latency. For human scales, this latency is negligible, creating the illusion of a shared present. We exist in a now bubble on the order of Earth-scale distances. The distance light can travel in the tens to hundreds of milliseconds. It takes the brain to integrate reality. Within this bubble, cause and effect seem simultaneous, but expand that scale and the synchronization collapses entirely. Consider a hypothetical sibling living on Proxima b4 light-years away. You might ask, what is my brother doing right now? In the Newtonian model, this is a valid question. In the relativistic model, the question is undefined. There is no right now that connects Earth and Proxima b. Because information is capped at the speed of light, his now and your now are completely disconnected sectors of reality. Depending on how fast you move towards or away from him, the mathematical slice of space-time that constitutes his present can swing wildly from his past to his future. This reveals a disturbing truth about the architecture of our universe. If there is no universal clock, and if now is just a local rendering artifact, then how can the universe maintain a coherent history? If time is not the fundamental backbone holding events together, what is? If now is merely a local synchronization error, and if different observers perceive different sequences of events depending on their motion, then we are forced to abandon the idea that the universe evolves one moment at a time. Instead, we must embrace a far more radical architectural model, the block universe. In this model, inspired by Einstein's unification of space and time, reality is not a fleeting sequence of presents. It is a single, completed geometric structure. Imagine the universe not as a movie playing on a screen, but as the entire reel of film laid out at once. Every moment that has ever happened, the Big Bang, the formation of Earth, your birth, and every moment that will ever happen, the death of the sun. The end of the cosmos exists simultaneously within this four-dimensional block. Think of this not as a literal block of ice, but as a static coordinate system. Just as north doesn't cease to exist when you travel south, the past doesn't vanish when you move into the future. They are simply different addresses in the bulk of space-time. The reason you cannot see the future is not because it doesn't exist yet, but because your biological consciousness is restricted to scanning the block one slice at a time. This explains why simultaneity fails. Different observers moving at different speeds are effectively slicing the space-time loaf at different angles. What you consider to be now is just a specific cross-section of the block. Another observer moving relative to you slices it differently. Their now might intersect with what you consider the deep past or what you consider the unwritten future. For the physics to hold together, all those events must be equally real. The structure is immutable. It is already built. This geometric architecture also provides the source code for the phenomenon of time dilation. Why does time slow down when you move fast? It is a matter of resource allocation. In special relativity, this idea can be described mathematically using something called four velocity. Its magnitude is always fixed at the speed of light for any object that has mass. This is your total system bandwidth. You cannot go faster and you cannot go slower. In this geometric view, your four velocity always has the same fixed magnitude, the speed of light. However, this velocity is shared between three directions in space and one direction in time. When you are sitting completely still, all of your motion is directed through time. You are aging at the fastest possible rate. But the moment you stand up and start walking, a small portion of that motion is redirected into movement through space. And to keep the total amount of motion constant, your motion through time must slow down. If you were to accelerate to a significant fraction of the speed of light, say in a high-speed spacecraft, you are reallocating the majority of your bandwidth to spatial travel. Consequently, your movement through time drops to a crawl. And if you could reach the speed of light like a photon, your allocation to space would be 100%. Your speed through time would hit 0. Along a photon's world line, the proper time between emission and absorption is 0. It is emitted and absorbed in the same instant, traversing the universe in a timeless suspension. This vector mathematics confirms that time is not a fundamental flow, but a navigational trade-off within a fixed geometry. We are simply tracing world lines, well-defined geometric paths through the static structure of spacetime. But this model introduces a terrifying paradox. If the block universe is static and the future is just as real as the past, why do we perceive such a violent difference between them? Why can we remember the past, but the future remains a wall of fog? If the architecture is symmetric, what created the arrow of time? If the block universe is a static crystal, why do we perceive a one-way street? We remember the past, but the future is blank. We see a glass shatter, but we never see shards leap from the floor to reassemble themselves. This apparent flow. The arrow of time is one of the most powerful illusions produced by our interaction with reality. The deception lies in the conflict between scale. At the microscopic level, the pixel level of atoms and molecules, the fundamental equations of physics are to an extraordinary degree time-symmetric. Whether you look at Newton's mechanics or Schrödinger's quantum equations, the math works equally well forward or backward. If you filmed two atoms colliding and played it in reverse, no physicist could tell you which version was real. At the fundamental level, there is no arrow. So where does the arrow come from? It emerges from our inability to see the details. It is a product of coarse graining, the blurriness of our vision. In the 19th century, Ludwig Boltzmann realized that what we call heat or disorder is simply missing information. When a glass shatters, the energy doesn't disappear, it disperses into the thermal motion of billions of air molecules and floor atoms. Theoretically, if you could track the exact position and motion of every single atom in the system, you could reverse the motion of every particle and reassemble the glass. But we cannot track that data. We lack the computing power. We see only the macroscopic result, a broken mess. This leads to a radical conclusion. Time as we experience it is not a force that pushes events forward. It is tightly correlated with the loss of accessible information. Think of the universe as a digital file. The deep past, the Big Bang, was a state of incredibly low entropy. In our analogy, this was a high-fidelity raw file. It was highly ordered, compact, and contained precise structural information. As the universe evolves, interactions scramble this information. We perceive the flow of time, because we are moving from a state of high information and order toward a state of low information and noise. We are watching the universe undergo lossy compression. In this thermodynamic picture, the future appears fuzzy not because it hasn't happened, but because entropy is higher. The data is more scattered, more generic, and harder to decode. Past and future are therefore not temporal directions. They are gradients of resolution. The past is the direction of high resolution. The future is the direction of pixelation and noise. We are trapped inside a biological system that links survival to the consumption of low-entropy resources, such as food and sunlight, creating the subjective experience of moving forward. But this is purely a perspective trick. However, even this thermodynamic arrow relies on the existence of states and changes. But what happens if we dig deeper past the atoms, past the blur, right down to the kernel of the code? What happens when we reach the Planck scale, where the resolution is absolute? We have peeled back the layers of relativity and entropy only to find distortions and blur. But to probe deeper, we must dig down to the bedrock where our best theories begin to break the domain of quantum gravity. It is here at the Planck scale that the most shocking anomaly in physics awaits. When physicists try to combine the laws that govern the very large with the laws that govern the very small, they run into a deep mathematical problem, known as the problem of time. The central equation that describes the quantum state of the entire universe is called the Wheeler-DeWitt equation. And when you examine this equation closely, you notice something deeply unsettling. Time itself is missing. In standard physics, equations describe how systems change as time moves forward. But in the Wheeler-DeWitt equation, the universe has no rate of change at all. The equation describes a single global quantum state that does not evolve relative to any external clock. It contains every possible configuration of matter and geometry, but it does not run. It simply exists. This suggests that at the kernel level, the universe has no clock cycle. It can be described as a static quantum state without an explicit time parameter. If the fundamental equation is static, how does the illusion of change emerge? The answer lies in the concept of quantum entanglement. In 1983, physicists Don Page and William Wooters proposed a mechanism to solve this paradox. They suggested that time is not a background stage, but a measure of correlation between subsystems. Imagine the universe is a static painting. In this painting, there is a clock reading 12:00 and a cat sleeping. Elsewhere in the painting, there is a clock reading 12:01 and a cat waking up. There is no movement between these two spots on the canvas. They exist simultaneously. However, because the state of the clock is quantumly entangled with the state of the cat, we can describe the cat relative to the clock. This is the Page-Wooters mechanism. Time emerges only when you split the universe into two parts, a clock and the rest of the system. An observer inside the system sees the clock tick and the system evolve. They are trapped in the correlation. But a hypothetical observer standing outside the universe looking at the global system would see absolutely nothing happen. The global quantum state remains static forever. In 2013, researchers at INRIM in Italy demonstrated a laboratory analog of this mechanism. They created a toy universe of entangled photons. They proved that for an internal observer, time appeared to flow. For an external observer, the system was frozen. We are those internal observers. We are trapped inside the equation, mistaking our correlation with the cosmos for a universal flow. But if physics says the flow is a lie, why is the feeling of now so undeniably visceral? The answer lies not in the stars, but in the circuitry of your own skull. Across physics, from relativity to quantum theory, we find no evidence of a fundamental universal flow of time. We found geometric blocks, entropy gradients, and static correlations. So where does the relentless, heartbeat-like sensation of passing time come from? It is not a property of the hardware, the universe, but of the biological processing systems embedded within it. Your consciousness does not perceive reality directly. It interacts with a processed simulation. A user interface evolved over millions of years to ensure survival, and like any complex interface, it has a significant processing latency. Consider the simple act of snapping your fingers. You see the motion and hear the sound simultaneously. But physics dictates that this is impossible. Light travels nearly instantly to your eyes, while sound crawls through the air at a much slower speed. Furthermore, the chemical signals from your ears and eyes travel through your nervous system at different velocities to reach the brain. In reality, your sensory data arrives in a chaotic, unsynchronized mess. If your brain displayed the raw data feed, reality would look like a poorly dubbed movie where the audio lags behind the video. To fix this, your brain holds the data in a short temporal buffer on the order of tens of milliseconds. It waits for all the inputs to arrive, synchronizes them, timestamps them, and only then projects the cohesive image into your conscious awareness. This means you are never living in the objective now. You are essentially living on a tape delay. The moment you perceive as this instant actually happened nearly a tenth of a second ago. Your conscious experience always lags slightly behind physical events, a post-processed render, rather than raw reality. But the interface goes deeper than just synchronization. To compensate for this neural lag, which would severely impair your ability to react to fast-moving threats, your brain engages a protocol known as predictive coding. Your brain does not just passively receive information, it actively generates a model of what should happen next. It projects a simulation of the immediate future, predicting the trajectory of the rock, the movement of the predator, and overlays this prediction onto your perception of the present. The flow of time you feel is the computational effort of your brain, constantly updating its internal model, checking its predictions against the sensory error logs coming from your eyes. We perceive time as linear and flowing, not because the universe is linear, but because causality is the logic of survival. An organism that perceives the block universe as a static whole would not know when to run. Evolution selected for a mind that artificially restricts its view to a single narrow slice, the cursor of the present, and moves it forward, discarding the past to save memory and simulating the future to save its life. In this view, time is not a direct window into reality, but a compression strategy one that allows finite biological systems to operate within a far larger, more complex structure. We began this investigation by diagnosing a glitch in our perception, and we ended by staring at a completely different reality. We have stripped the universe of its fundamental clock. We have seen that the river of time is just a blur caused by our lack of data, and the flow is a rendering trick of our biological interface. At first glance, the idea of a block universe, a static, frozen crystal where the future is as fixed as the past, feels like a prison. It seems to rob us of free will and agency. But there is another way to read this architecture. If the block universe is real, then time is not a thief. It does not steal the moments of your life and dissolve them into nothingness. In a relativistic universe, the past does not vanish. It remains there at its specific coordinates, just as real and solid as the ground beneath your feet. The days of your childhood, the moments of loss and the moments of triumph are not gone. They are simply located elsewhere in the geometry. Albert Einstein understood this profound consolation. When his lifelong friend Michel Besso died, Einstein wrote a letter to Besso's family saying, "Now he has departed from this strange world a little ahead of me. That means nothing." People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion. Einstein was not offering empty comfort. He was stating a physical fact. In the immutable architecture of spacetime, nothing is ever truly deleted. Your life is not a fleeting spark that disappears in the dark. It is a permanent glowing thread woven into the fabric of the cosmos. We are not victims of a river dragging us toward oblivion. We are explorers moving through a vast, completed library of existence. Our consciousness is the lantern we carry, illuminating the dark corridors of the block one moment at a time. The book is already written, yes, but the joy is in the reading. The silence of the equations is not empty. It is the silence of something eternal. Time is the illusion. You are the reality.